Congratulations to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. As much as it pains me to say, my fellow assassins, we are officially at that time of year where if you own a car and it spends any amount of time outside at all, it will perpetually look like hot dog doo-doo, basically 24/7 with all the pollen. Now, you can clean it, yes, but of course, within a matter of hours, it's already covered in that beautiful greenness, and of course I'm using that beautiful term sarcastically. Don't ask me how I know that. Which, in fairness, I don't think you even have to be a car owner to know that. You can literally just look outside and see cars around and see they are covered in this nice film, if you will. But anyway, that aside, let's get into this week's trivia question. Google Buzz, Google Friend Connect, and Orkut were all Google products that were retired attempts at a social media platform. What was their fourth attempt named? So, what was the name of Google's fourth attempt at a social media platform? And that is your trivia question for the week. And I'll tell you what, if Google is known for anything aside from the fact that they harvest tons and tons of user data and sell it to advertisers, it would probably have to be the fact that they just kill off basically every product they ever create. Like, it's kind of a meme at this point that whenever Google comes out with a new product, whether that's a software product or a hardware product, people are always, betting like, all right, what's the over-under on how long this product lasts? People are like, oh, I give it about a year, or someone like, I think 2 years, and then someone's like, I'm going to meet in the middle, 18 months, just because, Google has just been killing off so many products. I mean, there's like entire websites devoted specifically to all the products that Google has killed. I'm not exact. I think it's something like the Google Graveyard or something like that. If you search Google Graveyard, I'm sure you'll find a list of tons and tons of various killed Google products. But anyway, with that, let's get into this week's cybersecurity tip. So this week's cybersecurity tip is probably going to be focusing more towards enterprise people, but if you really want to be hardcore about your security, this definitely applies to you as well. And that is the idea of whitelisting applications. Now, essentially what this means is it's kind of a combination of minimizing the applications you have installed on your system to reduce the attack surface in combination with the principle of least privilege, which of course is this idea where you limit the access to any users or programs or anything like that to only have the minimum required access for them to perform their function. So essentially what the application whitelisting is kind of as the name might suggest, you essentially ban all applications from running except those that you whitelist or you explicitly say you are allowed to run on this system. So essentially if you try to run any kind of application installer or anything like that isn't whitelisted, it just won't work at all. So it kind of in a way, I won't say it gets rid of because, of course, with everything in cybersecurity, there is no silver bullet. nothing works 100% of the time. But it essentially removes the possibility of accidentally clicking on a malicious executable or something and having it launch malware on your system. Because unless you explicitly allowed that executable to run, it's not even going to be able to run and, deploy its payload or launch its attack or whatever it plans to be doing. So by doing this, you can essentially significantly reduce the risk of, like I said, any kind of malware infections or just unauthorized software installs in general, because I don't know if it's necessarily as common nowadays, but specifically like a few years ago, it used to be fairly common where if you downloaded, like say a Windows executable, for instance, and you went to install it, just because you were installing one application, sometimes applications would bundle other installers within them. So you think you would just be installing, say, like a web browser or something, but then you'd end up installing like 3 or 4 other different things. When you just randomly clicked next through all the menus, you would basically agree to installing other things. So that could additionally help prevent against things like that. And like I also said, it can also potentially also reduce your attack surface, because if you're limiting the number of applications and the applications specifically that you can run on your system, it basically prevents you from having more applications that could potentially be vulnerable. Because if you're running something like a server or an enterprise, of course, one thing you want to make sure about is you reduce your attack surface as much as possible. And the less number of applications you have, so the more minimal, I guess you could say, your system is, the less avenues attackers have to get into your system. There's less programs that they can try to find exploits in order to get into your system. So by whitelisting only the applications you want to be able to run, you can also potentially reduce your attack surface as well. So that is your cybersecurity tip for the week. So before we move into the nerdy stuff, I had kind of a thought this week that I wanted to get your guys' input on. So we talk a fair amount about software development and home labbing, and we even did, well, I think technically if you combine bits and pieces, multiple episodes, but I can think of at least one specifically where we talked about, all software developers should have a home lab. And it's come up on numerous other occasions as well, kind of this duo of, writing software or software development in general and having a home lab. So I was wondering, does software development and home labbing belong amongst the all-time greats when it comes to like the most iconic duos? And I before I even pose that question to you, I completely understand that this is a very elite select number of duos. I mean, there's a ton of them out there, and they're pretty synonymous with one another. But I mean, if software development and home labbing is going to be even mentioned amongst these all-time greats, I mean, it'd be going up against some fierce competition, right? Like, just off the top of my head, I mean, you got Salt and Pepper. I mean, pretty iconic duo if you are a breakfast enjoyer. Jordan and Pippin, Bacon and Eggs, Biscuits and Gravy, the Jedi and committing war crimes during the Clone Wars, Peanut Butter and Jelly, Milk and Cookies, and I mean, we could probably do an entire podcast episode about iconic duos, but this is not one of those podcasts. The point of that little example list there was mainly just to kind of go over, some of the very iconic duos and what software development and home labbing would be going up against should it be inducted into this one of the all-time greats when it comes to iconic duos. So I'm interested to hear what your thoughts are on if you think software development and home labbing have what it takes to be an iconic duo. So definitely be sure to let me know about that. And with that, let's get into what nerdy stuff have I been up to this week. So for this week's Scrum meeting, as it has, I don't know about affectionately being called is the right word, but kind of what it's been turned into, shall we say, over the past few months since I've been on a kind of sort of tear when it comes to software development. I tell you what, when I get free time, software development just seems to find its way into that free time. So as far as the video game I'm working on, the Pokemon game, it's making slow but steady progress, I'd say. So as I've been kind of touching on the past couple weeks, I've been working on actually getting the party screen implemented. So this week I got the full functionality of navigating around the screen implemented. Last week was mostly just focusing on some of the initial graphical elements, getting those in place, and some basic movement so I could kind of move the cursor around just to test to see that the graphical elements were working as I expected them to. But this week I kind of focused more on getting all of the navigational elements incorporated in there. So it like basically if you've ever played like one of the Gen 3 Pokemon games, right? And you go to the Pokemon summary screen, you have your first party Pokemon that is kind of in the bigger square, and then you have the other 5 slots that are just kind of rectangles. And if you're in one of those 5 slots and you hit the left arrow, you go back to the main one, the first slot. But if you hit the right arrow again, you'll go back to that same slot you were in, and it kind of remembers. So figuring out how to incorporate that, getting kind of a wraparound effect going so you can kind of cycle through them all, and just overall just getting that navigation working was what I was focusing on. And I did get the initial beginnings of kind of the option menu. I'm not exactly sure what to call it. I've been kind of internally referring to it as the what would you like to do with this Pokemon options menu, because that's kind of sort of what the dialogue text says in the game. But essentially, like when you select a Pokemon, like, what do you want to do with it? Do you want to view its summary? Do you want to switch it with another Pokemon in your party? Do you want to give it an item? That kind of a thing. So currently I have that menu displaying, and you can cycle through all the options, but you can't do anything with them yet. And the other thing I still need to do is make it dynamic, because currently it just displays 4 options regardless. So even if you can't switch a Pokemon, that still is listed as an option. It also doesn't include things like if you have special field moves, which like your HM moves, if you will, which technically I haven't really even decided yet what I want to do about HMs, because as a kid growing up, I remember they were always a pain, because you had your glorious team of 6, and then you had to go deposit someone in the box for the HM mule, or whatever you want to call it, the classic Zigzagoon or something, and bring them onto the party for whatever. And then of course you get to Gen 4 and you got to get the trusty Bidoof, am I right? But yeah, that one was also bad, with all the HMs you needed. So I understand the utility of them, right? Like blocking off sections of the game that you shouldn't access, so you can't access them too soon. So, but I kind of haven't gotten that far in the development process yet. Obviously, I'm still kind of working on some of the core fundamentals, like the building blocks. We haven't even gotten to story development or anything like that, which I think that would probably drive what I would do as far as like HMs or field moves or that kind of a thing. But I mean, that's not to say I haven't thought about the story at all. Like, I have some rough ideas for things, but I don't have like a fully fledged out, this is the map, this is the different towns, this is, the gyms, the storyline, none of that. I kind of just have a vague idea of what I want to do with it. So we definitely aren't there yet. And of course, even getting back on topic here, that options menu, there's still, once I implement some things, like right off the bat, I can implement the summary screen since that's already coded. I just have to link the two together, which technically it's already linked. It's just a matter of registering the key press to actually switching the screen over. So that shouldn't take too long to do. The switching Pokemon in the party, that also shouldn't take too long to do. All the back end code for how to switch Pokemon in the party already exists. It's just a matter of determining the user input to give it the proper parameters to swap Pokemon in the party. But then the big one is the items. That haven't even started on that yet. Have no bag whatsoever. Items doesn't exist. So that's another project. Well, I don't know, another thing that'll have to be worked out. But of course, eventually it'll have to be worked out. But it will be something that won't be implemented yet until, further down the line. But, still slow and steady progress. But, that's kind of how it goes, when you're working a full-time job and you're kind of only coding in your spare time. You only have so much extra time that you can devote to things like this. And like I said in some previous episodes, sometimes you can spend essentially another full-time job's worth of hours working on personal projects in a week, and other times you might be lucky to get an hour or two in. So it really just depends on the week and how much you can get done. But the main important thing above it all is that I wouldn't say make slow progress, because if you can really bang out some features, I mean, that's awesome. But it's mainly more about being able to make consistent progress and not burning yourself out and overdoing it. And kind of one of the ways that I've been trying to manage that better is better time management, I guess we'll say. Essentially looking at the time and first asking myself, okay, do I have enough time to devote to getting into this and, starting work on this? And if I do, trying to identify a good stopping point, and identifying a good stopping point ahead of time rather than in the moment. Because if I try to identify a good stopping time in the moment, I might have passed 5 or 6 good stopping points, and here we are 2-3 hours past when I actually wanted to do other things. So, trying to identify, a good stopping point and just kind of hard capping yourself and, not overdo it. Because one thing that I have often fallen into the trap of is, I don't know if biting off more than I can chew is the right word, but essentially I get to a good stopping point and I'm like, and I utter the infamous words, let me implement this feature real quick. And then, of course, implementing that feature real quick didn't go real quick. And then I'm frustrated and annoyed that we are way past when I wanted to be done and I have other things to do, but the code isn't working. And of course, me being me, I can't let the code not be working, so I keep pushing through, even though I definitely should have stopped hours ago. So trying to identify good stopping points is something that I've continually been trying to work on. But yeah, so that was another tangent. But yeah, that was essentially the nerdy stuff, mainly just some small features, but slow and steady wins the race, as they say. So now I kind of wanted to get into the kind of the main topic for the episode, which is We talked, I don't remember how many episodes it was ago. It might have been a couple months ago at this point, but we did an episode on why game development was so good for like learning software development and kind of going into all the various concepts in game development that help you better understand and learn software development. And I would say that writing your own HTTP or writing your own web server is probably a very, very close second, especially if you want to focus more on the networking and cybersecurity aspects. And I'd probably argue that if you do want to focus on the networking and cybersecurity aspects, the HTTP/web server is probably the better way to go, for a couple of reasons, as we'll get into. One of them being it's a lot quicker to code up an HTTP server than it is to write your own video game, for instance. And so, and one of the reasons why, writing an HTTP server, like why you'd want to do it is, like, first off, HTTP and HTTP servers are essentially the backbone of I won't say the internet, because the internet comprises a lot more of just the web. But when you think of like the web, things you can access through your web browser, or whenever you use tools like wget, curl, or any kind of REST API, for instance, or other things, you're interacting with web servers. So there's a lot of interacting with web servers or HTTP servers that goes on, even if you're not specifically using a web browser. So HTTP servers are one of the most common servers out there. So, trying to, and seeing that you basically are interacting with them on a daily basis, writing your own and kind of getting an understanding of how they work is definitely a good tool to have in your back pocket. Plus, I mean, at the core of it, an HTTP server kind of encompasses all of the components that a server has, because you have to process incoming requests, you have to handle them, process them, and then respond accordingly. Whether that's responding with the data the user requested, performing some action on the server side, returning some error message to let the user know what's going on. There's a lot of stuff that you have to account for when it comes to an HTTP server. And the nice thing about it is the HTTP protocol is so well documented. It's fairly, I'm not going to say it's easy to write, because if you're new to programming, it's probably a very, very daunting task. But if you have a fairly basic programming background, maybe you've done a little bit of networking, even if you haven't, if you have the ability to read and understand documentation, I mean, it's pretty much all laid out there, what you have to do. I mean, it pretty much goes in this sequence. You listen for a request from a client, and then once you get that request, you basically have to do some kind of processing of that request. So trying to identify what the user is requesting that you do, and then based on what they request you do, there's a whole host of potential responses an HTTP server can give. So essentially, you just kind of identify what they're wanting and respond accordingly. That's obviously very much simplified, but just kind of as a high-level overview, that is, in essence, what an HTTP server is. And if you think of any other kind of server, that's essentially what it does as well, but to varying degrees. Like, for instance, SSH servers or secure shell servers, they are sort of similar in the sense that they're just kind of sitting there listening for requests and handling them and responding to user input. The big difference, of course, there's more of an ongoing connection relationship with SSH, whereas HTTP isn't necessarily that way. So, I mean, but in essence, it's still that, same thing. You have a server that's waiting, listening for connections, handling them, and responding accordingly. Now, I think it also should be mentioned that when I say write an HTTP server, what I do not mean is that you have to write the next Apache or Nginx, web server that's going to run the internet. But at the very least, if you can get something working that can allow you to, through your own web browser, connect to your server and have it serve you, web pages and do things and interact like you would be with any other website, that's kind of what I'm talking about when it comes to writing your own HTTP server. So I also touched on, earlier, why game development is so good for software development in general. And some of the big reasons why game development is so good for learning software development is because of the vast kind of array of computer science topics that game development touches on, right? So it touches on, like as we discussed in that episode, it touches on things like algorithms, data structures, state machines, graphics. I mean, the list goes on. It pretty much hits everything that you would learn in a computer science degree. But other topics like networking and cybersecurity are definitely more hit or miss when it comes to game development, because depending on the game that you're trying to make, your game might not have any networking at all, in which case you wouldn't get any networking experience. And again, depending on how your users interact with your game, there also might not be much cybersecurity in place either, because if they're just interacting through like arrow key controls to move their player around and interact keys to like click dialogue through dialogue texts or select things like that are pre-canned on the screen, there really isn't a large attack surface there that an attacker could maliciously try to exploit your game through. Unlike an HTTP server, which the whole point of it is networking, and the idea of it being, essentially waiting for clients and interacting with clients. I mean, you're just asking for all kinds of cybersecurity, things to come up. So while you definitely could have some serious cybersecurity implications and networking hurdles that you would have to overcome with a video game, it's definitely very much dependent on the kind of game you're creating and is very much game specific. Because, like I said, not all games have networking, and depending on, again, like how you interact, there might not even be much of an attack surface. But the thing of it is, if you get into the industry and you have a desire to write software professionally, you're kind of going to be expected to not necessarily be a networking expert or a networking engineer or anything like that, but you're at least going to have some kind of understanding of how networking works and, how networking protocols work and how to connect to network devices, because unless you're building standalone applications that don't interact with anything, which is quite honestly pretty rare now, especially nowadays, you're going to almost certainly interact with networking code, or you might have to write networking code. And at the very least, the application you're working with is going to have some kind of networking code within it. So understanding, how networking works and how networking protocols work is definitely something that's vital if you have any desire to write software professionally. And in addition to that, being able to write secure code and being able to take cybersecurity, have cybersecurity in mind when you write your code rather than it being an afterthought and patching vulnerabilities when they come up. Being able to write secure code is also definitely something that would be a valuable asset for you if you desire to write code professionally. So with that kind of overview out of the way, let's kind of get back into the fundamentals of creating an HTTP server and why, it's so beneficial for these reasons. So first off, in order to create an HTTP server, you have to have some basic understanding of how networks work. So, for instance, HTTP, of course, works with the TCP protocol. So, unlike UDP, which is just fire and forget, TCP has kind of like this handshake process that goes on. So, you have to be able to understand how to create a TCP connection, for one thing, understanding things like IP addresses and how to network computers together, and then just in general network protocols. In this case specifically, it's of course going to be the HTTP protocol. And I guess one thing that I don't know if I should mention it, but just for awareness sake. So HTTP is kind of known for being on port 80. But in case you weren't aware, you can run an HTTP server on whatever port you want to. You could run HTTP on port 22, which is known as the SSH port. Obviously, that's not advised because you could potentially have some conflicts with an SSH server. But you could essentially run this on whatever port you want. Just in general, port 80 is reserved for HTTP, and then, of course, port 443 is reserved for HTTPS, which has that encryption aspect of it. But personally, I would focus on HTTP first before you try to get the whole encryption thing incorporated, because that just adds additional layers of complexity. So you definitely want to focus on the basics first, because even though HTTPS does add that encryption layer, which adds to your knowledge of cybersecurity, there still is a lot of cybersecurity fundamentals, which we'll get into here in a little bit, in just a generic unencrypted HTTP server. So kind of in addition to that, like I mentioned, in order to write an HTTP server, of course, you have to understand how the HTTP protocol works. So you have to understand, the various types of requests that HTTP can handle. So things like your GET requests, your push, delete, post, options. I think there's like 9 of them or something like that. Being able to understand them and how to parse them and how to handle them, understanding the headers that come with HTTP requests. So there's a decent amount of stuff that you kind of have to understand with how the HTTP protocol works in order to properly implement it. Now, kind of moving into the cybersecurity aspect of things. So the very nature of it being a server, in this case, is it interacts with clients and you are constantly dealing with user input. Essentially, aside from your initial setup process, where you set up your socket and you bind it to the port and the address and all that stuff, aside from that initial setup, basically everything you do within the HTTP server is based on user input. Because what does the HTTP server do? It sits there, waits for a client to connect to it, and then parses the request and responds accordingly. And every single one of those steps deals with user input. Now, you could argue the initial connection process is kind of handled at the operating system level or levels lower than your program. But the whole the big meat and potatoes of it, the processing the user request and responding, are entirely reliant on that user input. And as we've talked about countless times on the podcast, you can never trust user input. You essentially always have to assume that it's malicious. And if you don't assume that when writing an HTTP server, you're going to be in for a very bad time. So, because when you're writing an HTTP server, every request you get is user input, and you have no idea what that user input is. You have no idea if that user input is simply asking for your index.html page or if that user input is trying to delete the entire web server. You have absolutely no idea. So you have to understand and parse through methodically, what the user is actually requesting and basically be able to determine if their request is malicious or not, because quite frankly, you have no idea. So we even talked kind of about this last episode when we talked about, defensive coding strategies. So you're basically going to have to use all of them when writing an HTTP server, since not only do you have to ensure you're not blindly accepting user input, because doing so could, cause things like command injections or buffer overflows, various cybersecurity related attacks that attackers will try to exploit if you are running an HTTP server, but also ensuring that your server stays alive even in the midst of all this chaos. Because if you have any sort of public-facing server, I implore you to look at the log files for any open port. Like, for instance, I have a server running in the cloud and it has SSH open in order for me to remotely access it. And looking at those SSH logs, it's just getting hammered constantly from who knows who, from who knows where, trying to remotely log in and do malicious things. So if you're, going to be using this HTTP server, you can almost expect you'll be receiving similar malicious requests to your site, and being able to handle those and not crash and be able to keep the server online is definitely something that is very important, because this is a server after all, right? And a good server is one that has maximum uptime. Like, if you want to get into the data center realm, it's I don't know how many, they don't say 99% uptime. That's not good enough, in the server realm. We're talking how many nines worth of uptime? Is it 99.9? Is it 99.99999? The number of nines is what the determination of good is. If you're not even at 99, people won't even want to hear about you. You have to have multiple extra nines after the dot in order to even be considered. So yeah, maximum uptime is key when it comes to servers, because if your server is crashing every time you get a request that isn't exactly right or formatted specifically how it should be, you're going to have some serious problems. So being a server, it's kind of assumed that it will run more or less indefinitely. So also ensuring that you're not leaking memory all over the place is also vital, because if you're leaking memory and being a server, it's assumed it's going to keep running. If you're leaking memory, your process is going to hog more and more memory until it essentially has all the memory on the system, which could cause the program to crash, cause the entire system to crash, and essentially you not have a very good time. So yeah, those are some kind of big things, kind of harping back to last week's episode where we talked about, defensive coding strategies and, ensuring you're managing your memory, and of course, handling exceptions and errors, because you can almost be guaranteed that dealing with user input, you're going to get a lot of requests that are not properly formatted. And how do you handle that? There's probably also going to be a lot of instances where people are going to try to make a buffer overflow for your program. So how do you handle when a request has a lot more data than what you originally accounted for? Are you going to be resizing your buffer? Are you going to be just dropping the connection? There's a lot of things that you have to consider and edge cases you have to account for in order to ensure that your server doesn't crash and can't be exploited. So another problem that is kind of in the cybersecurity realm, and you'll see in just a bit here, is networking is very much an I/O operation or an input-output operation, meaning it's bottlenecked. If you've ever tried to write, say, to a file, you know that that is generally the slowest part of the program. And similarly, with networking, if you're just waiting for the user input on a connection, that's kind of what's known as a blocking call if you're using synchronous I/O, which essentially everything runs, in order. So if you're doing synchronous I/O when it comes to networking, if a client connects, for instance, but doesn't actually send a request, they're just connected, you're essentially just sitting there waiting for them to send you user input, and they're not sending anything, but you still have the connection active. So if you get enough of these, you essentially have a denial of service attack on your hands, which is definitely something that is going to be tried to be exploited against your server, is a denial of service attack. So how do you account for something like that? That's something that you have to account for if you're going to be writing a server. Now, there's a couple of ways that you can do this. But in essence, if you have any kind of server, you can almost guarantee you're going to get flooded with bogus requests, whether that's, them trying to do some kind of command injection, buffer overflow, denial of service, whatever the case may be. You have to figure out how are you going to handle all those bogus requests. Because if you just sit there and wait for the read to complete on the socket, and that connection just indefinitely remains open, it's just going to essentially hog resources, and your server is just going to come to a halt because it's just waiting for, clients to send it stuff when they're obviously not sending anything, and you have just succumbed to a denial of service attack. So how do you actually get around this? Well, it kind of depends on what your design philosophy is, but there's a couple ways that you can get around it. One of them is asynchronous sockets or asynchronous I/O. There's various implementations of this depending on, what programming language you're working in. The Boost library for C++ has a pretty fantastic asynchronous I/O socket implementation. You could also employ a multi-threading strategy where you kind of have a thread pool, for instance, and you have some kind of queue or some other data structure. Queue's probably the best one, where you have some kind of data structure that basically houses all of the incoming connections, and then when a thread is available, it basically pops the first one off the queue, handles it, and then you just keep going in that sense. So that would be another potential way to handle potential denial of service attacks, and also just having like timeouts in your program. So basically setting a timeout on the socket where if you don't actually get anything after so many milliseconds or so many seconds, however long you want to configure it, essentially just close the connection and move on to the next one. So there are definitely different ways you can handle that. Another approach you could take is if you actually employ some kind of load balancing solution. I mean, that's a little bit out of the scope of this episode since we're, focusing on HTTP servers specifically. But if you had a fleet of these servers deployed across multiple servers, that could be an instance where you have some kind of load balancer that would kind of try to help manage that, evenly distribute incoming connections to your various servers, or having something like Kubernetes running that could, dynamically scale and manage the connections that way. So there's definitely ways that you can handle the denial of service attack because it's definitely something you have to account for. But you can't only rely on those other strategies like scaling out across multiple servers or having a load balancer. You also have to have something in the server application itself to also try to help mitigate that as well. So just something that you should be accounting for when writing your program. So overall, though, creating a working HTTP server will provide you with a few key things. The first one is kind of a more in-depth knowledge of things like software development and software development practices, because of course you're going to be writing a fair bit of code here, writing tons of if statements, loops, and potentially creating data structures depending on which programming language you're in. How do you store waiting connections? What kind of data structure are you using for that? We kind of touched on maybe a queue, probably a queue. And the requests themselves, how are you storing the individual requests within your program? Are you using a class for that? Are you using a struct? Are you just having everything in individual variables and passing it around? Probably not a good solution. What kind of algorithms are you using to parse your user input and handle the input and determine what requests to respond back with? How to properly process that user input and handle those requests. So, how are you ensuring that your buffers are large enough to account for all the user input? How are you ensuring that your paths are actually valid for files you're trying to access? Things like that. Having a more in-depth knowledge of various defensive programming techniques, kind of like what we touched on in last week's episode, how to catch and handle errors, how to propagate those errors throughout the program, because I would hope you don't have just one massive function that handles everything. You're probably going to have multiple functions, some functions that call other functions, and you have kind of some levels of nesting going on. So how do you propagate those errors back up and handle, if you do encounter an error, sending that out accordingly? How do you prevent these errors and exceptions from crashing your program? Because as we touched on, you want to, since this is a server, you want to make sure you have as maximum uptime as you can, and having any kind of edge cases where your server could crash is definitely a way to kind of put a hamper on that. And then just in general, how to program defensively and, think of these edge cases and think of, how could something in this function fail and account for that accordingly? How could potentially miscellaneous or malformed user input affect how I'm processing this request here? How could that affect how I'm copying this buffer over to here? Various ways, and kind of trying to put your mindset in that of an attacker and kind of think of a malicious request throughout the entire flow of your program and how your server is handling that request. And another thing that would also be beneficial here is to write some test queries for your HTTP server. One thing that I've personally done when working with, server applications and including HTTP ones is write just a very basic client, an HTTP client that'll basically send out basic HTTP requests to test things. Some will be valid, some won't. Some will attempt to be malicious, some will try to overflow buffers, and just kind of coming up with things that I can think of that attackers would be trying against my server in order to ensure that I'm handling them properly and not leaking memory, not having memory errors, not timing out and, just sitting there waiting for the connection endlessly. And, things like this, ensuring that I'm, handling all those various edge cases. And then just in general, some cybersecurity fundamentals, because if you're able to write a HTTP server that's not extremely vulnerable to buffer overflows and command injections and denial of service attacks and things like that, in doing that, you kind of get a better understanding of how to write secure code, because one thing with writing secure code is preventing against, these common, software vulnerabilities. So being assuming that you successfully write an HTTP server, you should have gained an understanding of some of these common software vulnerabilities like buffer overflows and command injections, for instance. And just in general, the general idea of denial of service attacks in cybersecurity as well. So just kind of getting some of the core fundamentals and how to write secure code. So kind of in the end, while game development is quite honestly a fantastic way to understand the core concepts of software development with the wide array of, subject matters it touches on, I would argue that writing your own HTTP server does probably an equally as good of a job at helping you understand how to, but maybe not, covering all the topics as quite in depth per se. But one thing that I think writing your own server, in this case, an HTTP server, does is it helps you understand how to write robust software. So, understanding things like network-based programming, understanding things like defensive programming, error handling, cybersecurity fundamentals, and just ensuring you can write software that can take a few punches and keep going, right? Because in the real world, you're not always dealing with perfectly formed input because you can write all the test cases in the world that, handle everything with, perfectly formed input and requests that your server's expecting. But how does it handle when it gets, some kind of input that isn't what it's expecting? That's not to the HTTP spec. That is intentionally trying to be malicious. Being able to handle those kinds of requests as well, elegantly, not crash, propagate the errors, handle the errors, not have any kind of vulnerabilities. That is how you write robust software, and through concepts like secure coding and defensive programming. And in writing a successful HTTP server, you kind of gain those skills in the process. And as a last bonus that I will leave you with before we close out the episode, the last bonus is theoretically, if you write your own HTTP server, you could have it deploy in your home lab through a CI/CD pipeline. You could create your own continuous integration and continuous deployment pipeline. So anytime you make an update to your HTTP server, say you add a new feature capability, you add a new response code, you add a new request type that you support, whatever the case may be, whenever you make updates, you can push those updates and those can be automatically deployed in your home lab, and you can have your own HTTP server running in your home lab that you developed that took into account, all of the cybersecurity practices that we talked about, the secure coding, writing a robust piece of software. And there we go, another episode where we managed to hit on all of our big three: the software development, cybersecurity, and home lab concepts. So seeing as we just went out with that bang, let us get back to our trivia question and bring this episode home. So our trivia question for the week is: Google Buzz, Google Friend Connect, and Orkut were all Google products that were retired attempts at a social media platform. What was the fourth attempt named? So what was Google's fourth attempt at a social media platform named? If you said Google Plus, congratulations, you got this week's trivia question correct. So congratulations if you did. So if you enjoyed this episode, definitely leave a rating and review, subscribe, leave a comment, all that good stuff. And be sure to share this with friends or family members, because this is another one of those kind of core videos to help software developers, just in general, how to become better software developers, potential project ideas for them, writing a web server. And if you have any questions about this episode or have any comments or topics for future episodes, if you're on YouTube, you can leave a comment down below, or you can always shoot me an email at contact@darkassassinsinc.com. The link for that is down in the show notes or the description of the video as well. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.